Okay, so welcome back everyone. Um, okay, so before we really start understanding the relations and everything, first what we need to really understand is how the tracer experiments are, really done in with the reactors. Okay, so suppose I am having a reactor. Okay, this is my reactor. Okay, what I'm going to do is there would be a solvent, say suppose water. Okay, that is continuously being injected in and continuously being taken out. Okay, what I will do is I will inject say NaOH as my tracer. Okay, for every 5 or say 10 seconds. Okay, I would be collecting the samples. Okay, and then after I would be titrating them with HCl uh, to get what is the concentration of NaOH that I have really received in 10 seconds. Fine. Now, uh, let's suppose there is CSTR. Okay, let's suppose there is a CSTR in which this same experiment is being taken place. Okay, now this was my PFR basically. Now let's suppose there is a CSTR and the same experiment is being taken place or is being conducted with the CSTR. Now, what we really need to understand is as soon as my tracer is injected inside, this agitator is being agitated at a very high RPM. Okay, so it would take very less time, say suppose not 1 second, for example, for this concentration of NaOH to be exactly the same throughout the CSTR. Okay, I repeat, due to high agitation that is being taken place in the CSTR, as soon as I am going to enter my tracer in the CSTR, it would be taking almost a negligible time compared to my sampling time for the concentration to be 100% equal throughout the reactor. Okay, so say suppose at zero time when I'm going to see the concentration of my CSTR, say suppose the NaOH that I'm going to add is of 5 molar concentration. Okay, now at zero time when I'm going to really start my sampling, the concentration inside would be 5 molar. Okay, because this is taking like a very small time as compared to my sampling time. Okay, so for my sampling time to be 0, or at my sampling time as 0, this concentration is 5 molar, or rather we can say there is an assumption that at time 0 the concentration has to be 100% equal throughout the reactor, the CSTR. Okay, now as I said, the water is continuously flowing and the samples are being taken out. Okay, now here my sampling is, I'm doing my sampling. Okay, fine. What's next? So as soon as I'm starting to collect my sample, do you think all of the NaOH is going to come out at one shot completely? No, right? So what I can say is, if I say I'm plotting T versus ET for the CSTR, okay, for CSTR, so at zero time, my concentration will be the highest. Say for example, 5 molar. Okay, with as the time goes on, as the time passes, As the water is continuously flowing in, the concentration will go on dropping and dropping and dropping. Okay, so it would be something like this. Okay, this is the case with CSTR. Okay, now this was the case when it is just there is just one CSTR. Okay, there is just one CSTR with me. Now think of a system with two CSTRs. Okay, fine. I have again injected 5 molars of NaOH, water being continuously coming in, agitator is being continuously, I mean the water in the CSTR is being continuously agitated. Fine. Now for this first CSTR, this is our exit age distribution. Okay, but what for this? Can you think of? Try to think over this. Try to make a graph by yourself. Try to think how this concentration is really going to come out of the CSTR. Try to make your own assumptions. Try to really draw this graph. Try to understand how it will move. The answer for this question would be given in the next video. But before that, you yourself try to really plot how the change or how the exit is distribution of the NaOH or the concentration of NaOH is going to be plotted for the E curve. Okay, so that's all for the video. Let's meet in the next video.